Hello, algebra students. Mr. Lawrence here, and we are going to do something that you are going to think is really cool. You're going to feel really smart, but you have to be preparing and have to be watching the videos. If you don't, oh well, you're going to miss out. And I got to warn you, if any of you try to tell me that this is too difficult, I'll bring one of my pre-algebra kids in here, and they will do it for you. They know how. This is too easy. Now, this is going to be something that before you used to do at such a low level, and I'm not sure why they held you to such a low expectation, meaning the state, but we are going to do it at a much deeper level. Okay, first thing is, remember back maybe last year, maybe a couple of years ago, when they had something like this. They gave you some numbers, 3, 6, 9, 12, 15, and they asked you to tell them what the next three numbers were. Okay, now as smart as you guys are, this is too easy, and it probably should have been a little bit insulting, and maybe that's part of the problem. Maybe some of you guys have been insulted by how simple the math has been in past years. But we are going to take it to a whole new level. We are not going to look for, the next three terms. We are going to write a formula or a function that will allow us to find any term we want. We could find the 30th term, we could find the 500th term, the millionth term if we needed to. And we're not going to have to list them all out. Okay? So our tools to do this are going to be what's called an input-output table. And we're going to use x and f of x. Now you see down here I have f of x. And what that means is I might have some equation or expression like 3x plus 1. And if x is a certain number, like maybe 1, 2, 3, I will just simply, f of x means I just simply put that number in x's place and then do the math. Yeah, I just put it into the expression. I basically just substitute it in. In fact, not even basically, that's exactly what I do. So this f of x, don't let it bother you. It tells you what you get out for an answer from your function. All right, now we're going to be finding the nth term, and the nth term is just some unknown number. Okay, now stop and think about it for a second. If I count all the way up to n, I count 1, 2, 3, all the way up to some number n, what number comes immediately after n? Now, some of you are, maybe a little confused by this, but you shouldn't be. You're honors algebra students, or even in regular algebra. Let's see here. 1, 2, 3. How do I move from 1 to 2? Well, don't I add 1? And from 2 to 3, don't I add 1? Right? But if I counted all the way up to 17, the next number would be 18, wouldn't it? How do I get there? I add 1. Maybe I counted to 72. The next number would be 73, right? How do I get there? I add 1. So what number would come after n? Well, I take the previous number n and I add 1 to it. What number would come next? Well, an n plus 2. Hey, what number would come before n? Well, you should probably know. N minus 1, right? N minus 2. So n is just some unknown number that, we're going to discover an expression for or a function for, but we don't actually know its value. Okay, so we talked about that. Let's look at this first sequence of numbers. It goes 4, 7, 10, 13, 16, and then it goes on forever. Here's what I do first of all. I'm going to fill these numbers in for f of x. These are the f of x numbers. These are the answers. Okay, the first one, number 1, is 4. The second one is 7. The third one is 10. That's what the 1, 2, 3, 4, 5 mean. Okay, the fourth one is 13. Fifth one is 16. I don't know n, I don't know the 30th one. Now what I do is I find the first differences. So I come down here and I see, well, this is plus 3. How do I move from 4 to 7? Plus 3. This is called the first differences. And I notice that when I go from 7 to 10, I also have to add 3. 10 to 13, I have to add 3. And 13 to 16, I have to add 3. Notice how all my first differences are the same. Since my first difference is the same, this means my pattern or my expression or my function is going to be linear. And it's really simple. The nth term is going to be something like this number, this plus 3, times n, times n. So what I'm going to do, I'll move this over here, and in another color, I'm going to write down here 3n. This 4, 7, 10, 13, 16 sequence is going to behave something like a 3n pattern. My expression might be 3n. What I'm going to do is I'm going to do a comparison line. This orange line is called a comparison line. And I'm going to put these numbers 1, 2, 3, 4, and 5 in for n. So 3 times 1 is 3. 3 times 2 is 6, 9, 12, 15. And now I'm going to compare. I'm going to ask myself, how do I turn 3 into 4? Well, I add 1. How do I turn 6 into 7? I add 1. 9 to 10, I add 1. You have to check on 3 of them. If you check on less than 3, you'll be wrong sometimes. If you check all 5, you'll never be wrong. But they're all add 1, aren't they? Well, that means that my nth term must be something like 3n plus 1. 3n plus 1. Okay? And now I can write an equation. I can go f of x is going to equal 3x plus 1. Now, why do you think I used x instead of n? Well, because I'm just writing the general equation. And remember, these top ones are my x numbers. My bottom ones are my f of x's, my answers, what I get out of the function. So I'm going to plug 30 into my equation, which gets me 3 times 30 plus 1. Found the order of operations, I get 90 plus 1. I get 91. And there you go. All right, so we found a linear pattern. Yeah, this was a linear pattern of numbers. Okay, to the first power. Let's test this one. I've got 6, 11, 16, 21, 26. Some of you might be catching on already. We'll put it in 11, 16, 21, 26, looking for the nth term. So I go looking for my first differences again. Plus 5, plus 5, uh, plus 5, plus 5. All right, my first differences are the same. This is going to be linear again. And I'm going to use something. I know it's going to be something like this plus 5 number times n. So I'm going to write 5n down here and do my comparison line. So I take all these numbers and I multiply them by 5. 5, 10, 15, 20, 25. Okay, now I compare up. It looks like in this case I'm going to add 1 again, right? I'm going to add 1 every time. So my answer for n is going to be 5n plus 1. Now it won't always be plus 1, it just happened to be a coincidence there. In fact, I'm going to show you one that's not plus 1 in just a second. I come over here for my equation, f of x is going to equal 5 times x plus 1. I substitute in 30. I get 5 times 30 plus 1, which should be 151. And there you go. All right, now hold on one sec. Okay, I wanted to show you one that was going to be linear, but a little bit different. I actually filled the sequence into the table already to save time. I'm going to find my first differences, and I notice I have minus 3, minus 3, 1 minus 3, negative 2 minus 3. So this is going to be something like negative 3n. And I put my numbers in. I get negative 3, negative 6, negative 9, negative 12, negative 15. All right, do my comparison. First differences are the same, so it's still a linear pattern, right? Okay, how do I turn negative 7 into, oh, excuse me, negative 3 into 7? Well, I think I might add 10. Let's see here. How about negative 15 to negative 5? Does that add 10? Yeah, it sure does. Negative 15 plus 10 is negative 5. Negative 9 plus 10 is 1, right? So that means my nth term is going to be negative 3n plus 10. My equation, of course, will be f of x. That will equal negative 3x plus 10. And if I put 30 in there, negative 3 times 30 plus 10, I get negative 90 plus 10, negative 80. All right, there we go. Now, not all patterns are linear. Let's see what happens on this one. I've got 0, 3, 8, 15, 24. Okay. Um, I go for my first differences. Looks like plus 3, plus 5, plus 7, plus 9. They're not matching, are they? I'm going to try going down to my second difference. So that's my first difference. My second difference. Okay, look, plus 2, plus 2, plus 2. When the second difference is the same, when the second difference is the same, are you listening, Andrew? When the second difference is the same, my pattern is something like n squared. Yeah, it's quadratic. Right. It's a quadratic pattern. I don't actually use this plus 2. This plus 2 will always show up if it's a quadratic pattern, but I don't actually use the 2. Some of you go, well, the 2 goes to the exponent. But when we do a cubic one, it won't be that way. It won't be a 3 in the problem. So anyway, um, don't worry about that. There is a pattern hiding in there, and if you discover it, want to share it with me, that's wonderful. But for the purposes of doing these, we're not going to worry about what the 2 means. We're going to worry that we're on the second difference, so we have to do n squared. All right, so now I'm going to square 1, 2, 3, 4, and 5. Well, that'd be 1, 4, 9, 16, and 25. And then I'm going to compare up. How do I turn 1 to 0? Well, I subtract 1. 4 to 3, I subtract 1. 9 to 8, you got it, subtract 1. So my nth term is n squared minus 1. Okay, my equation would be f of x, equation of my function, n squared minus 1. So I do f of 30, which means I do 30 squared minus 1. Now make sure you use parentheses when you substitute in. I've been telling you guys that for a long time, and some of you choose to ignore me, and then you get answers wrong. 899 is your answer here. Okay, this video is getting a little long, but I got a couple more examples to go through. I'll try to do this one a little bit faster. Looks like I have a negative 4, a negative 7, a negative 12, a negative 19, and a negative 28. Going for my first differences, I subtract 3, I subtract 5, I subtract 7, I subtract 9. First differences don't match. I know it's not linear. I'll go down to the next level. Negative 2, negative 2, negative 2. Ooh, it's going to be quadratic, right? The only problem is you got to account for this negative. It's not going to be n squared. It's going to be the negative of n squared. And remember your order of operations, exponents will come before subtraction. So you'll do the exponent first. So I'm going to square 1, then make it negative. I'm going to square 2, make it negative. It is not negative 1 times negative 1. That is not what this means. I have to follow the order of operations, so I have to do negative of 1 squared like that. So I square 1, make it negative. 3 will be negative 9, negative 16 for 4, and negative 25. Now, how do I turn negative 1 into negative 4? Well, I subtract 3. Negative 25 to negative 28, I subtract 3. So I'm going to get negative n squared minus 3. All right, so f of x will equal negative of x squared minus 3. So I'll do f of 30, and I'll get the negative of 30 squared minus 3. Well, this is 900, negative 900 minus 3 is a negative 903. Okay, now number 5 is a little bit different. 7, 14, 33, 70, 131. You might notice the numbers are jumping a little bit quicker here. So I'm going to go for my first difference is plus 7. Oh, what is that? Is it 19? Yeah, I think so. 37? Yeah. And 61. Okay, and then I get plus 12 and plus 18, and I believe that's plus 24. The second differences didn't match. The first was different. The second is different. But watch what happens when I go to the third differences. I get plus 6 and plus 6. Since the third difference is the same, I'll bet Gotham can tell me that it's going to be something like n to the third power. Notice I didn't get a 3 there. Okay, so the third difference is the same, n to the third. So I'm going to cube all these numbers. I'm going to get 1, 8, 27, 64, and 125. So how do I turn 1 into 7? Well, I add 6. 8 to 14, add 6. 125 to 131, add 6. So I'm going to get n cubed plus 6. So my function is going to be f of x, and that's going to equal x cubed plus 6. And by the way, this would be a cubic function, right? This is cubic. So f of 30 and 30 cubed plus 6. Now, I can do this one in my head pretty well. I know 30 squared is 900, and 900 times 30 is going to be 27123. When you get to some problems of this magnitude, and we're not looking for an easy one to do in your head, I don't mind you using a calculator for here. Okay, I don't want to see it for like, plus 3 or minus 7 or something like that. But for the big stuff, it's okay. So I'm going to have 27,006 is my answer here. So 27,006 is the 30th number in the sequence. That's growing pretty quick, isn't it? Okay, one more and then we'll wrap this video up. And I'm going to put 0, 6, 24, 60, 120. And I'm going to find my first differences. It looks like I got a 6, an 18, 36, right? And a 60. First differences don't match. I go down to the second level. Plus 12, plus 18, plus 24. I'll bet you can see it. It's going to be plus 6, plus 6. That's the third difference. This is going to be a cubic. And so it's going to be something like n cubed. So my cubes are these numbers in orange, and then I compare them. I subtract 1. Here, 8 to 6, I'm subtracting 2. Oh, that's weird. 27 to 24, I subtract 3. 64 to 60, I subtract 4. 125 to 120, I subtract 5. It's different every time. I subtract 1, subtract 2, subtract 3, subtract 4, subtract 5. I wonder what I'm going to do here. Oh, let's see. On the 5th one, I subtracted 5. What do you think I'll subtract on the 12th one? I'll bet I subtract 12. On the 18th one, do you think I'll subtract 18? Yeah, that sounds right. How about on the 172nd one? Well, I think I'll subtract 172. What am I going to subtract on the 3000th one? 3000. So what do I subtract on the nth one? N. Yes, I subtract n. My nth term is going to be n cubed minus n. So my function, my equation of my function will be this. And then when I do f of 30, and I do 30 cubed, and I take away 30. And I think this was 27,000 from the last problem, right? Minus 30 should be 26,970, right? And there we go. All right, that's it for the video. I think you're going to like doing these. They're actually pretty cool. All right, Mr. Lawrence signing off. Good night, everybody.